China has been just rolling out its military might. Some experts say the world should be watching pretty carefully.
And that's a concern in and of itself, that if we have drones flying around military bases and we can't identify where they came from or who's responsible.
Michael McCaul is right. The Pentagon doesn't know, because what they just watched was footage of China's new GJX stealth drone. And they realized they've been played for fools.
My judgment, based on my experience, is that those that are over our military sites are adversarial and most likely are coming from the People's Republic of China.
Those mysterious drones McCaul identified as Chinese, they're testing technology that's now integrated into the GJX, a 42-meter stealth aircraft that's a carbon copy of American technology systematically stolen through university programs and defense contractor partnerships.
We need to know who is behind that because I believe they're spy drones. And the PRC, Chinese, Communist China, is very good at this stuff. And we know they bought land around military bases. This would be very consistent with their policy over the last couple of years.
McCaul says China is very good at this stuff, and he has no idea how right he is. Between 2000 and 2015, over 3,000 Chinese researchers worked inside American aerospace facilities, learned how to build stealth aircraft, then went back to China and built the GJX, using everything they learned from us.
The parade unveiling AI drones, including an unmanned submarine drone, as well as a stealth attack drone being called the Loyal Wingman that can fly alongside manned aircraft.
These are the advanced capabilities China publicly displayed. But the GJX represents something far more dangerous. The Pentagon knows this because the drone's radar-absorbent materials are identical to classified American formulas that were developed in UCLA laboratories by Chinese graduate students.
We could see them use these military capabilities against U.S. national security interests in the Indo-Pacific region, specifically going after Taiwan, but not necessarily just Taiwan, but we're closely aligned with Japan and South Korea.
The GJX has the range and stealth characteristics to operate undetected over Taiwan, giving China the ability to conduct constant surveillance of American military positions without triggering any early warning systems. Chinese military planners can now map every American base, track every ship movement, and monitor every defensive position in real time before launching any attack. Pentagon officials are panicking because China just proved they can build anything America can build using American knowledge. And now, they have the surveillance capabilities to strike Taiwan without warning. The GJX looks exactly like American stealth aircraft because it was designed by people who learned how to build stealth aircraft in American universities. Dr. Wang Zhenguo spent 4 years at UCLA studying radar-absorbent materials under Professor Sarah Chen, who was simultaneously consulting for Lockheed Martin's classified programs. When Wang returned to Beijing in 2004, he took those material formulas with him. UCLA didn't know Wang was documenting everything he learned, because his research was completely legal and covered by normal academic freedom policies. He published papers about his work, presented at conferences, and shared data with other researchers, just like any graduate student would. The problem was that Wang's academic research involved the same materials used in America's most secret aircraft. By 2008, Wang was working at the Chinese Academy of Sciences, producing radar-absorbent coatings that matched American military specifications exactly. The coatings worked because they used the same chemical compositions, the same manufacturing processes, and the same testing procedures that Wang had learned at UCLA. China didn't reverse engineer American technology. They learned it directly from American professors. The GJX's stealth design incorporates techniques that were developed at Stanford University's aerospace program, where 47 Chinese researchers studied between 2000 and 2010. These students worked on DARPA-funded projects involving hypersonic vehicle design, electromagnetic signature reduction, and advanced composite materials. Every single one of them returned to China and now works in Chinese military aviation programs. Stanford professors thought they were training the next generation of international aerospace engineers, but they were actually teaching Chinese military researchers how to build weapons that could be used against American forces. The university received millions of dollars in research funding, while unknowingly transferring decades of American military research to China's defense establishment. But Wang and his Stanford colleagues weren't working alone. They were part of a much larger operation that involved America's biggest defense contractors. While Chinese researchers like Wang were learning stealth technology in American universities, Chinese engineers were simultaneously gaining access to manufacturing secrets through partnerships with major defense contractors. Boeing gave Chinese engineers access to advanced composite manufacturing techniques through a partnership with Commercial Aircraft Corporation of China that was approved by the Commerce Department in 2011. The Boeing partnership included detailed specifications for composite aircraft structures, manufacturing equipment, and quality control procedures that are identical to those used in stealth aircraft production. Chinese engineers received 6 months of hands-on training at Boeing facilities, where they learned techniques that took American engineers 20 years to develop. This training built directly on the theoretical knowledge that researchers like Wang had acquired in university programs. Lockheed Martin's joint venture with China Aviation Industry Corporation transferred manufacturing specifications for advanced aircraft structures through a technology licensing agreement designed for civilian aircraft production. Chinese engineers gained access to materials science breakthroughs, manufacturing processes, and design methodologies that were later applied to the GJX development program, creating a perfect combination of university research and industrial production capabilities. General Electric provided Chinese companies with turbofan engine technology through licensing agreements that included detailed specifications for reducing infrared signatures and acoustic emissions. These technologies are critical for stealth aircraft operations, and Chinese engineers now use identical techniques in their military aircraft engines, completing the propulsion systems needed for aircraft designed using university-acquired stealth knowledge. Raytheon shared radar technology with Chinese research institutions through partnerships focused on civilian air traffic control systems. The collaboration provided Chinese researchers with comprehensive knowledge of radar operation principles, signal processing techniques, and electronic countermeasures that directly supported stealth aircraft design efforts, by teaching them exactly what their stealth aircraft needed to avoid. Every major American defense contractor participated in these technology transfer programs because they wanted access to Chinese manufacturing capabilities and markets. The companies made billions of dollars while teaching Chinese engineers how to build weapons that now threaten American military superiority. But these contractor partnerships were just one part of a comprehensive technology acquisition strategy that extended deep into America's university system. The defense contractor partnerships worked so effectively because they built on a foundation of academic collaboration that had been training Chinese military engineers for decades. MIT hosted Chinese researchers through academic exchange programs that provided access to classified research facilities and defense contractor laboratories, creating a pipeline of trained personnel who could immediately apply their knowledge in industrial settings. The MIT program included Professor Liu Mingshan, who spent 6 years studying hypersonic vehicle design before returning to Beijing University of Aeronautics and Astronautics in 2009. Liu's research involved wind tunnel testing of aircraft configurations that are virtually identical to the GJX's planform design. And his work was funded through O&R grants that gave him access to classified test facilities where he learned techniques that Wang's material science research made possible. Listing: building comprehensive picture. Georgia Institute of Technology maintained partnerships with Lockheed Martin, Boeing, and Northrop Grumman, while simultaneously hosting Chinese researchers through academic exchange programs. These partnerships provided Chinese nationals with access to test facilities, manufacturing equipment, and engineering databases containing specifications for advanced military systems, allowing them to see how university research translated into actual weapons production. Caltech's aerospace engineering program trained Chinese students who later became senior engineers in China's stealth aircraft programs. These students worked on projects involving electromagnetic signature reduction, advanced materials development, and flight control systems that are directly applicable to military aircraft design. building on the materials knowledge that researchers like Wang had developed and the manufacturing expertise that defense contractor partnerships had provided. The University of Michigan's aerospace program provided Chinese researchers with access to wind tunnel facilities, computational fluid dynamics software, and structural analysis tools that were essential for aircraft development. Chinese participants in these programs maintained detailed documentation of testing procedures and design methodologies that were later used in Chinese military programs, creating comprehensive technical databases that supported projects like the GJX. American universities thought they were promoting international scientific cooperation and generating research funding, but they were actually running training programs for Chinese military engineers who would apply their knowledge in coordination with defense contractor partnerships. The academic exchange programs operated completely legally, while systematically transferring American military technology to China's defense establishment. But the coordination of these seemingly separate programs revealed a much more sophisticated intelligence operation. The university programs and defense contractor partnerships weren't random occurrences. They were carefully coordinated components of a comprehensive intelligence operation that used legitimate academic and commercial channels to acquire American military technology. The China Scholarship Council funded over 5,000 Chinese students studying aerospace engineering at American universities between 2000 and 2015, with specific requirements that participants focus on research areas aligned with Chinese military development priorities. Students like Wang and Liu were expected to acquire detailed technical knowledge and maintain comprehensive documentation of their research activities, which they could later combine with manufacturing expertise gained through defense contractor partnerships. This coordination ensured that China acquired both theoretical knowledge and practical application capabilities for every technology they targeted. Chinese technology companies established American subsidiaries that hired former defense contractor employees and acquired access to technical databases, manufacturing specifications, and engineering documentation. These companies operated legitimate businesses while systematically collecting information that supported Chinese military research programs, creating bridges between university research and industrial application. Professional conferences and academic symposiums provided opportunities for Chinese researchers to establish relationships with American scientists working on classified programs. These relationships facilitated ongoing information sharing that continued after Chinese participants returned to military research positions in China, maintaining channels for updating their knowledge as American technology continued advancing. The Thousand Talents program recruited American researchers to work in Chinese universities and research institutions, providing them with substantial financial incentives to relocate and continue their research in China. Many participants brought detailed knowledge of American military technologies and continued working in areas directly related to defense applications, accelerating Chinese development by incorporating ongoing American research advances. Chinese intelligence services coordinated these academic and commercial programs through organizations that operated openly within American research institutions. The program succeeded because they exploited legitimate channels for scientific collaboration, while systematically acquiring technologies that supported Chinese military capabilities. But the intelligence coordination required sophisticated manufacturing networks to transform acquired knowledge into operational weapons. The intelligence operations' success depended on China's ability to transform acquired knowledge into operational weapon systems, which required building manufacturing networks that could replicate American production capabilities. Shenyang Aircraft Corporation built composite manufacturing capabilities using equipment and processes licensed from American companies, initially for civilian aircraft production, but later applied to military programs, including stealth aircraft development. The manufacturing techniques were identical to those used in American defense facilities, because Chinese engineers had learned them through defense contractor partnerships, while Chinese researchers provided the theoretical knowledge needed to optimize production processes. This combination enabled Shenyang to produce components that met the same specifications as American manufacturers. Chengdu Aircraft Industry Group acquired precision machining equipment from American manufacturers, along with comprehensive training programs for operating advanced manufacturing systems. This equipment produced aircraft components requiring extremely precise tolerances for stealth applications, capabilities that China acquired through direct technology transfer rather than independent development, building on knowledge gained through university programs and contractor partnerships. Xi'an Aircraft Industrial Corporation established research and development facilities using design software and engineering tools licensed from American companies. These tools included computational fluid dynamics programs, electromagnetic modeling software, and structural analysis systems that were essential for stealth aircraft development, allowing Chinese engineers to apply their acquired knowledge using the same tools that American engineers used. Chinese companies systematically identified critical manufacturing capabilities and acquired them through partnerships, licensing agreements, and direct equipment purchases from American suppliers. The manufacturing network that produced GJX components relied entirely on American-developed processes, equipment, and expertise acquired through legitimate commercial relationships that complemented the knowledge gained through university programs and intelligence operations. The technology transfer succeeded because American companies wanted access to Chinese markets and manufacturing capabilities, while Chinese companies systematically acquired the knowledge needed to replicate American military production capabilities. Both sides achieved their immediate objectives while creating long-term strategic advantages for China. But the ultimate success of this strategy became evident when China began producing weapons that incorporated all the acquired technologies. Building climax that comprehends technology. The comprehensive technology acquisition strategy that combined university research, defense contractor partnerships, intelligence operations, and manufacturing development culminated in weapons systems that incorporated decades of American research and development. The GJX stealth drone represents just one component of China's military modernization program that demonstrates listing achievements matter of fact. Chinese engineers used American-acquired knowledge to develop multiple aircraft platforms, including the J-20 stealth fighter, H-20 stealth bomber, and various unmanned systems that incorporate materials developed by researchers like Wang, manufacturing techniques learned through contractor partnerships, and design methodologies acquired through university programs. China's stealth aircraft capabilities now rival American systems because they were developed using American technology, American-trained personnel, and American-developed manufacturing processes. The GJX's counter-shaded paint scheme uses Wang's radar-absorbent materials. Its aerodynamic design incorporates Lu's hypersonic research, and its manufacturing relies on techniques learned through Boeing and Lockheed Martin partnerships. The FC-31 stealth fighter incorporates engine technology acquired through General Electric licensing agreements, avionics systems developed with American components, and manufacturing techniques learned through Boeing partnerships. Chinese engineers didn't reverse engineer these capabilities. They acquired them directly through the comprehensive technology transfer programs that operated across multiple sectors simultaneously. China's hypersonic weapons program benefited from research conducted by Chinese nationals in American universities and national laboratories, demonstrating how the same acquisition strategies applied across different weapons categories. The DF-17 hypersonic glide vehicle uses guidance systems and materials that were developed through collaborative research programs involving American institutions. Chinese military satellites incorporate technologies acquired through commercial space partnerships with American companies, providing targeting data for Chinese weapon systems and enabling communications networks that support military operations across the Indo-Pacific region. The systematic technology acquisition program enabled China to develop military capabilities in 15 years that would have required 50 years of independent research and development. But this success created strategic challenges that American policymakers are struggling to address. The comprehensive technology acquisition program that produced the GJX and other Chinese weapons systems created strategic vulnerabilities that Pentagon officials cannot address through traditional military responses. China's military capabilities were built using American technology and American-trained personnel, giving China permanent access to capabilities that were supposed to remain exclusively American. American defense contractors now compete against Chinese companies that possess identical manufacturing capabilities and technical knowledge, acquired through partnerships and licensing agreements. This competition disadvantages American companies that invested in developing these technologies, while enabling Chinese competitors to produce equivalent systems at significantly lower costs, using knowledge acquired through university programs and contractor partnerships. The GJX flight tests demonstrate that China can now develop and deploy advanced military systems faster than America can respond with countermeasures, because Chinese engineers have access to the same design tools, manufacturing processes, and technical knowledge that American engineers use. The comprehensive technology acquisition eliminated traditional American advantages in military technology development. Intelligence assessments indicate that China's technology acquisition programs continue operating through academic institutions, research collaborations, and commercial partnerships that appear completely legitimate. American universities and companies resist restrictions on international cooperation, making it impossible to prevent ongoing technology transfer that builds on the successful strategies that produce the GJX. The strategic situation requires fundamental changes in how America manages technology security while maintaining the scientific and commercial relationships that support economic growth. But current policies cannot prevent technology transfer that occurs through legitimate academic and commercial channels that have operated successfully for decades. China's successful acquisition of stealth aircraft capabilities represents a broader pattern of systematic technology transfer that extends across all areas of advanced military technology. Chinese engineers now possess detailed knowledge of American missile systems, submarine technology, satellite capabilities, and cybersecurity systems acquired through similar comprehensive programs that combine university research, contractor partnerships, intelligence operations, and manufacturing development. The GJX proves that China can now build any weapon system that America can build because the comprehensive technology acquisition strategy that produced it continues operating across all areas of military technology development. The 42-meter stealth drone isn't just an impressive achievement. It's evidence that China has permanently acquired the capability to match American military development using American knowledge and American-trained personnel. American military superiority depended on maintaining exclusive access to advanced technologies. But that exclusivity has been permanently compromised through the systematic exploitation of academic collaborations, commercial partnerships, and defense contractor relationships. The strategic advantage that took America 70 years to develop was acquired by China in 15 years. Through coordinated programs that continue operating today. The October 2025 flight test footage represents China's confidence that they can now publicly display capabilities that were previously secret because they possess the manufacturing infrastructure, technical knowledge, and trained personnel to produce these systems at scale. Chinese military planners no longer need to conceal their capabilities because they have achieved technological parity with American systems across multiple weapons categories. Pentagon officials cannot prevent Chinese access to American technology because the transfer occurs through legitimate channels that support American economic interests and scientific advancement. Universities depend on international collaboration for research funding. Defense contractors need global markets for commercial viability, and technology companies require international partnerships for competitiveness, creating systemic vulnerabilities that cannot be addressed without fundamental changes to American institutions. The strategic challenge extends beyond military competition to include economic rivalry in civilian markets, where Chinese companies now compete using technologies acquired through comprehensive programs that combine university research, contractor partnerships, intelligence operations, and manufacturing development. This competition threatens American leadership in aerospace, electronics, and advanced manufacturing sectors that support both civilian and military applications. China's systematic technology acquisition strategy succeeded because it exploited fundamental characteristics of American society, including openness in scientific research, international collaboration in higher education, and commercial relationships that prioritize short-term profits over long-term strategic considerations. The same institutional characteristics that support American innovation and economic growth created vulnerabilities that enabled comprehensive technology transfer. The GJX stealth drone represents the culmination of the most successful technology transfer operation in history. enabling China to acquire advanced military capabilities without the decades of research and development that were required for American achievement. Chinese engineers now use American knowledge to build weapons that could be used against American forces, creating strategic vulnerabilities that cannot be easily addressed because they result from fundamental characteristics of American institutions. The comprehensive technology acquisition strategy that produced the GJX demonstrates that China can systematically acquire any American military technology through coordinated programs that exploit legitimate academic, commercial, and industrial relationships. American policymakers must now develop responses to strategic competition from an adversary that possesses equivalent military technologies while maintaining the openness and international engagement that support American economic and scientific leadership. Anyway, that's it for the video, folks. Bye.